In this video, we are going to see some different types of problems where we apply the slope-intercept form. So in these examples, we want to answer two questions. One is write the equation in slope-intercept form, which is y equals mx plus b, if possible, and determine the slope and y-intercept. Then part B, graph the equation using the slope and y-intercept. So in example 2, to put this equation in the slope-intercept form, that means we need to get y by itself. So I'm going to move the term 2x to the right side by subtracting 2x. These two will cancel, and then we are left with 3y on the left. Then 6 minus 2x. Notice that 6 and 2x are not like terms, so you cannot combine them. Next, to get y by itself, I am going to divide both sides by 3. So on the right side, when I divide both of these terms by 3, it's the same as dividing each term by 3. So I'm going to separate the divide by 3 here. And then on the left, we should end up with y. And on the right side, 6 divided by 3 gives you 2. And then minus 2/3 times x. You can also rewrite this as negative 2/3 x plus 2, so it looks exactly like mx plus b with the x term come first. Now we determine the slope and y-intercept. So the slope is the coefficient in front of x, so that should be negative 2/3. Or I can write negative 2 then over 3. Then the y-intercept, so the y-intercept is b, but we want to write the y-intercept in order pair form because it is a point. So we are going to write 0, 2. Now part B, we are going to graph the equation using the slope and y-intercept. Now the slope is negative 2 over 3. This is where we are going to use the concept rise over run to see how the line behaves. So with rise over run, rise is the numerator and run is the denominator. Rise refers to going up or down, and run refers to going left or right. So with rise being negative 2, that means you need to move down 2 units. And with run equals to 3, it means that we need to go to the right 3 units. So if you end up with a negative 3 instead of positive 3, it would be going to the left 3 units. And if you end up with positive 2 in the numerator, that would mean going up 2 units. Okay, so now when you graph, the first thing you want to do is to plot the y-intercept, the point 0, 2, which is going to be this point right here. Then you'll use the behavior, rise over run behavior, to find the second point and third point and fourth point and so on. So from the y-intercept that you already plotted, you are going to apply going down 2 units and to the right 2 units. So down 2 and to the right 3, that will put us right here. You can do more. Down 2 to the right 3, it'll put us here for the next point. And 3 points should be enough for you to graph the line. Technically, you only need 2, but 3 will help us connect the line a little better. So now we are going to connect all these dots to get the line. Make sure you draw beyond these points and put arrows so it indicates that the line goes on forever to infinity and negative infinity. All right, so example 3. Here we have x equals negative 3. So what's special about this one is it's missing a y variable. Whenever you see an equation that is missing one of the 2 variables, that means you're going to end up with one of the 2 special scenarios, which is either a vertical line or a horizontal line. So with x equals negative 3, what it means is x is always going to be negative 3 no matter what y is. So you can pick any points that you want as long as x is -3, I could do -3, 2. I just make up the value for y. And next point could be -3, say 4. Okay, so let's plot these 2 points. So -3, 2. That's going to be right here. And then we have -3, 4. So -3, and then 4. So up 4. It's right here. And then you connect these points, and then you get, as you can see, you get a vertical line. All right. So with the y variables missing, obviously we can't write this in slope-intercept form. But in the previous video, we talked about the slope of a line, the special cases. So let's look back. Here, these two special cases. So when m is 0, then we expect to get a horizontal line. And when m is undefined, we should expect to get a vertical line. So with this graph that we just drew being a vertical line, that means the slope should be undefined. But let's see how we can determine that using the slope formula. So the slope is calculated by y2 minus y1 over x2 minus x1. And let's say we name this x1, y1, x2, y2. You can always reverse the role too if you want. The first point could totally be x2, y2. Second point be x1, y1. So plugging in the values, y2 is 4, minus y1 is 2, and then over x2 is -3 minus x1, so minus a -3. So the numerator should be 2, denominator will become -3 plus 3, which gives you 0. As you can see, we end up with 0 in the denominator. Therefore, this fraction is undefined, and therefore the slope is undefined. So the slope of a vertical line is always undefined. Example 4. In this example, we're missing the x variable. So we technically can put it in the slope-intercept form. Let's first divide both sides by 2 so we can get y by itself. So y is equal to 2. You could write in slope-intercept form by rewriting this as 0 times x plus 2. Now 0 times x is just 0. 0 plus 2 is 2. So I didn't change the value of the equation. But now you can see that the slope m is 0 and the y-intercept b is 2. So with the same explanation like example 3, y equals 2 means that y is always going to be 2 no matter what x is. So you could just pick any 2 points as long as y is always 2. So I could do 0, 2 as 1 point, and I could also do -2, 2, just 2 random points there. So this time I'm going to plot the 2 points in green. So we have 0, 2, that's going to be this point. And then we have -2, 2, that's going to be this point right here. And now I connect the 2 dots, and as you can see, I end up with a horizontal line with the slope being 0. You can also calculate the slope using the formula m equals y2 minus y1 over x2 minus x1. So we can name this x1, y1, x2, y2, and then we get y2 is 2 minus y1 is 2, and the denominator x2 is -2 minus x1 is 0, so we end up with 0 over -2. 0 over -2 is equal to 0, so the slope is 0. Now we find the slope for both example 3 and example 4. Let's look at the y-intercept for each example. So example 3, as you can see, the pink graph doesn't cross or intersect the y-axis at all. So there's no y-intercept for example 3. No y-intercept. Example 4, the y-intercept, there is actually a b value that exists. So the y-intercept is the 0.02. As you can also see, the green graph here, it intersects with the y-axis at the 0.02. Example 5. Write an equation of the line that passes through the given point -8, 1, and 0, -3. Let's first write the slope-intercept form. Okay, to be able to write this equation, you need to find two things, the slope and the y-intercept. And after you find the values for m and b, you can just plug them in and you can write the equation in general form with x and y being the variables. So let's calculate the slope. We already know how to do that. Name the points. y2 is -3, y1 is 1. x2 is 0, minus x1 is -8. So the numerator should be -4, and the denominator should be +8, and that will reduce to -1/2. So we found b. Now to find m, you need to use one of the 2 points given. Maybe some of you recognize that this right here is the y-intercept because it has x equals 0. So then the answer should be quickly determined since b is going to be -3. So y is equal to -1/2, which is the m we just found, x, then -3. But hypothetically, if you didn't recognize that that is the y-intercept, there's another way, and it's not always that they give you the y-intercept as one of the points. So here's what you do instead. So with y equals mx plus b, let's say we use the point -8, 1. -8 is x and 1 is a y coordinate. We are going to plug them in here in this equation. So we are looking at 1, which is y is equal to m is -1/2 and x is -8, and then plus b. We just have to solve for b. So the left side is 1. The right side, -1/2 times -8, that's going to be a positive answer. You can make 8 over 1 and multiply straight across. So -1 times -8 is 8. 8 divided by 2 is 4. And then you subtract 4 from both sides, and that should give you b is equal to -3. And once you find b, then you can write the equation the same way, and you will get the same answer. You could also use the point 0, -3, plug them in, do the same thing, and you should end up with the same equation.